Okay, so today we're going to talk about rational numbers. So we're going to write rational numbers as fractions, and we're going to identify and classify rational numbers. So it says, Mr. Marsh makes banana waffles every Saturday morning. His recipe is shown at the right. So we have a couple questions it's wanting us to answer. Which measures are written as whole numbers? Well, if you look it through here, you could look at whole numbers as 1 teaspoon of cinnamon, 1 teaspoon of baking powder, 2 egg whites whipped. Okay, those would be whole numbers. Which measures are written as fractions or mixed numbers? Well, a half a cup, that would be a fraction. 1.5 cups, that would be a mixed number. And then which measures are written as integers? So again, 2 egg whites, 2 would be an example of an integer. Okay? All right, so we can organize numbers into rational number or into number sets. Okay? So when you first learned to count using the numbers 1, 2, 3, and so on, you were using members of the set of natural numbers represented by an uppercase N or capital N. And then you added 0 to that. And when you add zeros to a set of natural numbers, now you have a set of whole numbers. So whole numbers are represented by a capital W, 0, 1, 2, 3, and so forth. And then when you add your negative numbers to that, you have integers, which is represented by a capital Z. So your integers are your negative number whole numbers, your 0, and your counting numbers. Okay? And then any number that can be written as a fraction is part of a set called rational numbers, represented by a capital Q. Some examples of rational numbers are shown here. We have terminating decimals like 0.87 is a rational number. We have negative 23, which is a whole number, which is an integer, and that it can be written as a fraction, so it's a rational number. Of course, 2/3 is a fraction, so it will be a rational number. And then negative 2.56 repeating is a repeating decimal, and you'll see in this lesson how you can write that as a fraction, so that would be a rational number. And then a mixed number like 1.5 is a rational number. Okay, so that's some examples. So our first little exercise here says, write each number as a fraction. So if we're going to write 3 2/5 as a fraction, we go from the denominator, work this way, up. Okay, so it would be 5 times 3, which gives me 15, and then I add the numerator, which will give me 17, and then I keep the denominator, so 17 over 5, okay? And then if I have an integer like negative 7, remember I can put a 1 underneath it in the denominator and make it a fraction, so negative 7 over 1. So let's look at a couple of guided practice. We have 4 2/3. We need to write that as a fraction. Again, we're going this way. So 3 times 4 is going to be 12, plus 2 gives me 14, and put it over the denominator, so 14 over 3. Okay? And then 7, again, we could just put 7 over 1, and that would be a fraction. Okay? All right. So now let's talk about fractions, mixed numbers, and integers are all rational numbers. So terminating decimals are also rational numbers because they can be written as a fraction with a denominator of 10, 100, 1,000, and so forth. Okay? So we are to write 0.64 or 64 hundredths as a fraction in simplest form. So when you look here, the 4, which is the last digit, is in the hundred spot. So all we have to do is take that 64 hundredths and put 64 over 100. And then we will want to simplify. So what can go into the numerator and denominator evenly? Well, 64 divided by 4 is 16, and 100 divided by 4 is 25. So we could divide the numerator and denominator by 4 and simplify that down to 16/25. Okay? All right. A handheld video game system weighs 9.675 ounces, or 9 675 thousandths, ounces. Write this decimal as a mixed number in simplest form. Again, when we look at it, the 5 is in the thousand spot. So we're going to take the 675 and put it over 1,000. And then we simplify that down. We could divide the numerator and denominator both by 25, and we'll get 27 over 40. And then we continue to bring our whole number down, so we have 9 and 27/40. Okay? All right. So let's look at some examples you try. So write each decimal as a fraction or mixed number in simplest form. So go ahead and try these, then come back and see how you did. All right, so 0.84 or 84 hundredths. So I'd simply just put 84 over 100, and then I can simplify that down. So I could divide the numerator and the denominator by 4, and I'm going to end up with 21 over 25. Okay? And then the next one, I have 5 and 875 thousandths. So 5, and then I'd put 875 over 1,000. And then I can take 875 and divide it by 125, and 1,000 divided by 125, and I'm going to end up with 5 and 7/8. Now, if you weren't sure that that was 125, I could simply, that 5 would go into both of those, so I could divide both by 5, and then 5 again, and keep going until I get to where I can in simplest form, and that's 5 and 7/8. Okay? Now, rock music accounted for 35 hundredths of the total music sales in recent year. Write the decimal as a fraction in simplest form. So since it's 35 hundredths, we would put 35 over 100. Then we just have to simplify. 5 goes into 35 7 times, and 5 goes into 100 20 times. So 7 over 20 would be your answer simplified. Okay? All right, so now we're going to look at repeating decimals and how to write them as fractions. So we are to write 0.6 repeating as a fraction in simplest form. All right, so step 1. We are going to create an equation, and we're just going to say n equals that repeating decimal, 0.6 repeating. Now, since I only have one repeating number, then I'm going to multiply that equation by 10. Okay? So that's step 2. And when I do that, I end up with 10n equals 6.666 repeating. Okay? Now, I want to subtract the original equation that I made in step 1. Okay? This is going to be step 3. Now, when I subtract that, remember this is a 1 in front of that n. So 10 minus 1 is 9. 9n equals 6.6 repeating, and I'm going to subtract 0.6 repeating. That's going to leave me with a 6. And then I just simply solve, which is step 4. So divide both sides by 9, and n equals 6 over 9, or 2/3. Okay? Don't worry, we got a couple more examples here to look at. We have 0.5 repeating. So that's the same as 0.555. So again, we set up our equation, n equals 0.555. Now, there's only one repeating number, so we multiply both sides by 10. When you do that, you get 10n equals 5.55 repeating. Then we go back and we take our original equation and we subtract it from that. And so when we subtract 10n equals 5.5 repeating, and we subtract 1n, which equals 0.5 repeating, we end up with 9n equals 5. We then divide both sides by 9, and n equals 5/9. Okay? All right. So we are to write 0.42 with the 42 both repeating as a fraction in simplest form. So again, step 1. Let's write this as n equals 0.4242 repeating. Okay? Now, we have 2 repeating numbers. So we will have to multiply this times 100. If we had 3 repeating numbers, we'd have to multiply it times 1,000 and so on. Okay? But 2, so it's 100. That's going to give me 100n equals 42.4242 repeating. Then I subtract my original one, which is 1n, and 0.4242. That's going to give me 99n equals 42. Okay? Now I just divide both sides by 99 because 99n would be multiplication. The opposite of multiplication is division. So when we divide, we get n equals 42 over 99. Or we need to simplify this. And so I could simplify this by 3. And I would end up with 14 over 33 would be my answer. Okay? All right. So now let's talk about identifying and classifying rational numbers. All rational numbers can be written as terminating or repeating decimals. Decimals that neither terminate nor repeat, such as the numbers below, are called irrational numbers. So things like pi, 3.141592, it goes on forever and doesn't stop. That is an irrational number, okay? So a rational number is any number that can be expressed as the quotient or the answer to a division problem, a over b, where b does not equal 0, okay? Or a fraction that the denominator is not 0. And here's some examples of what it can be. Now remember that an integer would also be a whole number and a natural number, or could be a whole number and it could be a natural number. But a natural number may not necessarily be an integer. For example, the number 8, which is a natural number, would also be a whole number, and it would also be an integer. And it would also be a rational number. However, negative 45, for example, is not a whole number and is not a natural number. So it doesn't necessarily go down, but it does go the other direction. Okay? Just something to keep in mind. So we are to classify or identify all sets to which each number belongs. So negative 0.08 or negative 800ths. It is not a whole number and it's not an integer. Okay? But it can be written as a fraction of negative 8 over 100. So it is a rational, just a rational number. 19. 19 can be a whole number. It can be an integer, and it's also a rational number. So I write down all 3 things. And then 8.28, 228, 2228 it's not repeating. It doesn't terminate it. Those ... means it goes on and on. So therefore, it is an irrational number. Okay? And then negative 8 is an integer, and it's also a rational number. So I'd list it twice. Okay? All right, so how about 0? What would 0 be? All right, when you look at 0, 0 is right here. It's a whole number. Okay, but it's also an integer. And I could put 0 over 1, so it's also a rational number. Okay? 1 4/5 is a mixed number, so therefore it is only a rational number. And then for C, 1.41421356 means it goes on and on forever. it would be an irrational number. Okay? All right. If you got any questions, let me know. Have a good day.